All right, hello and welcome to the AI First Show. This is the show where we talk about all things AI and AI first, meaning before we try to do anything by ourselves, we try to do it with AI that helps us push the limits, push the frontiers of how we're using it. My name is Stephen Barr, and introduce my co-host, Leonardo Gonzales. Welcome everyone to the live stream.
Hi. So today I wanted to talk about 3 different things that have a common theme. All of them are in various stages of leading edge or cutting edge, some in a viral stage, some in most people don't know it exists stage, and some in a lot of people have heard of it for a while stage.
And remember, with AI timelines, that window can shift in like a month, right? This is a very fast moving world we live in here.
Yeah, for sure. I'm going to go through a Google Slides presentation that I did, a teaser version of this, like a 8-minute presentation. Obviously, today we can actually go into detail. And I'll just share awkwardly that I'm a little unprepared. I just landed from a flight and had a busy weekend. So the plus side is, instead of a highly polished, efficient demo, we'll maybe get into the weeds of how to actually configure and set things up. So it'll be a little bit more of a workshop that could be valuable in its own way.
I think that actually those end up working really well. And we're here, we're all builders, or want to be builders. So I think getting into the thick of it, I think that's perfect. For those of you on the stream, I see we've got a bunch of people on YouTube and on Twitch. Make sure you can ask questions, and we'll post your questions. We'll get to them as we go. So please make this interactive. We are here for you. So yeah, let's jump into it. Today we're talking about Open Prose, Prose.md. See, yes, let's just jump into it.
All right, I'm going to start sharing my screen.
All right.
Go entire screen. You all see my screen now?
There we go. Okay, let's have a look.
All right, so I pulled up one of Andrej Karpathy's biggest banger posts on X. Sure, almost everyone knows who he is. He's kind of an AI rock star, OpenAI co-founder. The hottest new programming language is English. He posted this about 2 years ago. 3 years ago, sorry, it's 2026. And this has various iterations over time, and I feel like now it's having yet another layer of relevance. This is not his most viewed tweet, but I just saw that he's got it pinned. So it's maybe his favorite post on X. And the fact that English can be a programming language is fascinating. And I'm going to show that it's not just because of vibe coding in an IDE, but it's because of using your prompts and your context as actual flow control or orchestration in your software development processes or automation workflows. So the overarching theme of all of this is using Markdown to orchestrate things and having this hybrid between unstructured information that is English language and semi-structured information that is Markdown with maybe various flavors of schemas or ways that it is used. And there's so many benefits to this. One is that it's easy to review, it's easy to audit, it's versionable, it's portable across different tools. It's something that can be understood by people of different technical leanings, and it is highly token efficient. So Markdown as an overall format is being highly adopted for various different things.
You know, it's funny. This reminds me of, there's always this, they say there's nothing new. But the original goal, I don't know if you've ever seen COBOL, but COBOL, which came out in the 1960s, that was the goal of COBOL, was to have like an English-like programming language. And, at that time, like if you look at COBOL, given that it was 1960s technology, right, it would say procedure, perform, function. And the way they did it, like, it was very revolutionary for its time, given the alternative was punch cards, right? So to have something that you could actually specify in English was extraordinary. But now we're looking at it, that depended on, of course, the compiler to take the exact form of English and bring it down into machine code. Now we're taking it from the other way, where it's like, it's almost the same thing, right? We're trying to be specific about the way we're using English so that we're precise.
Yeah, and well, what's amazing now is we're able to combine syntax for non-ambiguous instructions along with AI interpretation of kind of free-form writing. And that's something that Prose does an interesting job of. So the three things I'm going to talk about are the agent skills standard. Just as maybe people have heard of agents.md. MD is not only a file name extension, but a top-level domain. So it's kind of funny. You can put in agents.md in your browser, and you'll see a page about the emerging standard of having agents.md, which is basically a prompt injection into your IDEs or coding agent harness to give long-standing instructions across sessions about your repo. This has become an emerging standard and is being adopted by all these different tools that you see here. So that's pretty fascinating. There's this new one called skill.md. And this is called the Agent Skills Stanford. Here they redirect you. Agent Skills Standard, which is a way of different agent harnesses incorporating instructions on demand. So that's a skill.md. Or agentskills.io. What is really good about having this on demand is you don't blow up your context window. So this is more efficient than, say, loading in 50 MCP servers, because part of the standard is we just have a name and a description. And that gets loaded. And then based on that, the agent can determine which skills to then fully load and read the rest of the file. And then the rest of the file is marked down. So this is called front matter for those that are not familiar with it. It's YAML. So it's like you got a few standard fields. And then the rest of the file is a markdown. It can be anything.
So as an example of a skill, maybe if you're using Git and you have a particular rebase strategy that you really want to use, you can write that up, and then when you tell your agent, right, I want to do my rebase, and then it can load in your essay of how you like to use Git, or maybe you have a database that you want to talk to in a certain way, right? And that's the idea of a skill.
Even a Git commit message, like if you want to say, use a semantic commit message, make sure the summary line is under 50 characters, blah, blah, blah. It saves you from having to do an extensive prompt every single time. It allows you to standardize. It allows you to go into great detail. And it allows you to reuse it and port it to your various tools that you want to use. So skills are things that you can develop yourself. There are also things that can be shared among the developer community. And that's part of the great portability, is across different tools and across different people and companies, these things emerge, just like MCP servers where people share different skills. And actually, the second and third things that I'm going to talk about are skills. They can be loaded as skills. So the first one is definitely a kind of a prerequisite. It will be a natural progression to talk about these. But just in high-level detail, I already mentioned kind of what skills are. The second one is Ralph, after the Ralph Wiggum Simpsons character. This is a guy who's not terribly intelligent, but he just has a famous saying of I'm helping, I'm helpful. And the way that this has been described by some people is just feeding a prompt over and over and over to an LLM until it gets it right, or bashing your head against the wall until it works. Like there's a little bit of a brute force element here through just sheer iteration. So the beauty is in how it's designed and how it's orchestrated. There's an external orchestration. There's a loop that's essentially like a bash script. And it goes through and it kind of picks up a structured spec that has priorities and has a description that is decomposed of the different tasks that need to be done, and a way to verify that they are correct. So there's a little bit of test-driven development, so to speak, where there's a verifiable way to say, hey, this quote-unquote works. So by doing that, you can have an unequivocal record of whether something is done or not. And every iteration, you get a fresh context, and you just work on one task, and you work on it until it's done, and then you mark it as done, and you exit. And then you enter the loop again with fresh context to work on one task. So this is in stark contrast to one-shotting a big, powerful model, a spec, and saying, implement it all, where you've got some harnesses that are better than others. I've been definitely championing Factory Droid and Open Hands as two of the most powerful long horizon agent harnesses, where you can get more traction than Windsurf or Cursor or various IDEs for passing it a multi-page spec and just having it implement it end to end. This inverts the paradigm a little bit. Instead of saying, oh gosh, implement it all, do it all, it says pick one thing and do it. And then just repeat, pick one thing and do it, pick one thing and do it. So the amazing thing here is not only do you not blow out your context and maybe have to deal with imperfect compaction or condensation processes to compress your context, but you kind of have a structured approach to limit your scope and do one thing at a time. And people have reported running this for a couple of hours, for 8 hours, for 20 hours. So this thing just runs autonomously for hours to days at a time. And will obviously burn through insane amounts of tokens, but will get things done. And by having a good process to verify, it's a powerful tool. This is the one that Skills has been around for a while. Some people are just kind of learning about it or starting to adopt it. This has become viral. This was a blog post about 7 months ago or so, but over the last couple of weeks has started to become viral. The third thing is a little bit ahead of the curve. Not a lot of people have heard of Open Prose. That's something you can go to Prose.md to find about. And it's interesting because looking back at this Karpathy tweet, or X post they're called now, he replied about a month later saying, oh gosh, this blew up. Let me show some things that are interesting about this. One was talking about in-context learning and being kind of quote unquote programmed inside the prompt, which is a little bit of like what Ralph does, but it's also more about like what Prose does, especially one of these things where he talks about building a virtual machine inside of ChatGPT. One of the things that Open Prose does is it kind of creates this runtime environment, so to speak, where the orchestrator is inside the conversation. So instead of having something like LangChain or Crew AI, where you have a multi-agent orchestration system or framework, this is all done by a text file inside the runtime. So you basically just specify your control flow and your agents inside of a markdown document. And in your conversation with the LLM, the processing, just works. So it's kind of a very interesting inversion of flow, inversion of control, and very experimental, but promising and interesting, and even as just a kind of an experiment, but also it could be like a new area to develop, a new area to explore. I'm gonna show. I've tried and run this. I've used this quite a bit, and I've started to use Ralph. I haven't run it for 10 hours at a time, but there are some kind of semi-official integrations into various agent harnesses that I'm gonna show. Any comments or questions so far, Stephen, on the overview?
So skills are a set of instructions written in English in Markdown that the LLM can have access to what the skill is, and then if it needs that skill, it could read the whole thing. So that's skills. And then Ralph is a bash script and also like a way of thinking which says, iterate on this over and over and over again. So instead of telling the LLM, build my whole app, it can build up a spec or a to-do list, and Ralph can then go say, pick the next thing on the to-do list, do it, save it, and then on the outer loop, so outside the LLM, well, from the LLM's perspective, it gets instantiated with, here's the state of the world, here's the thing I need to work on, and then I'll go and do it.
Exactly,
and then, typically when we think of programming, we think of like flow control as an if and while and for loops, and if this happens, then do this. And we think of that as a very mechanical thing. But then we're saying with OpenProse, we're defining semantics for flow control, but inside of an LLM. So you're not saying like with the way a CPU would branch one way or the other.
Mm-hmm.
It's saying you're an LLM, and if that happens, do this, and otherwise do that. And your flow control is in the quote like consciousness of the LLM, or in the brain of the LLM.
It's a good way of combining kind of a hard spec determinism with AI interpretability. And I'll show how those two things get combined with a specific syntax, because it's pretty fascinating. Like you could have a simple branch, like, if this thing is good, then do this. But well, how do you define if this thing is good? Well, that's a subjective thing that's open to interpretation. And so that's where the AI can, evaluate that phrase, and based on that, execute its flow control.
And so I wonder that the analogy could be made. I don't know if you've ever been to like a Toastmasters meeting, but if you do like Robert's Rules of Order, where it's like, I make a motion, I second this motion, we're going to have a discussion. And it's like a very structured way of having a conversation. And so we can almost think of Prose as like Robert's Rules of Order for getting things done with LLMs.
Yeah. I mean, I think there's a common theme across all of these. It's the integration of structured and unstructured information, and the integration of human-defined and AI-created knowledge and work. Yeah.
All right, let's check it out.
So let's start with skills, with agent skills, because it's the foundational thing that's driving everything. It's essentially a folder. So your folder will, have some kind of a snake case, usually name of whatever your skill is. And then inside the folder, you've got a skill.md file. You can have other files that the skill tells you to load. So this is how you can intelligently manage context in several layers. Your first layer is, and this is what we refer to as progressive disclosure. First thing you do is the discovery. You read only the name and the description. So this is very sparse, very light. You can load, dozens of these into your context. It's not going to blow your context window. It's just a name and a description. And this is going to help with discovery and loading of the skill in two different ways. You can manually invoke a skill. You can say, hey, load the whatever skill. And because there's this directory of skills, your agent's going to know, oh, I know that skill. I'm going to load the skill.md file from that directory and into my context. Another way is implicitly. You can say, process this PDF, right? And if you have a PDF processing skill, then it knows all the skills that it has, and it says, of all the skills that I have, this PDF processing skill is the most relevant one. So I'm going to load that skill, and then I'm going to, do things there. So that's the first and second layer, is loading the skills. When loading the skill.md file, you can have different functions in there, different things that you could trigger in IDEs through like / commands or things like that, and that gets into specific integrations. But they can refer to external things. They can refer to other files, external databases, programs to run, and things like that. So it's yet another layer of progressive use of tools and loading of things into context. So again, this is very context efficient. You can use everything that you need, but exactly when you need it and only when you need it. When you combine this with other things like iteration with a fresh context for each cycle, then you really use your context window to its maximum potential by keeping it lean, but by also loading everything that it needs to do whatever task you have at hand.
I think that's an important thing for people to understand, and it took me a while to get this. Like when you see context window is, you know, 1 million tokens, right? That's kind of the edge right now, is 1 million tokens. It doesn't mean that the thing that you read 990,000 tokens ago is like front and center in the LLM's attention, and it will 100% get that right? Like if you said the way to access my database is blah blah blah, and then gave it 900,000 extra tokens, it might not pay much attention to that special instruction that you gave it. And so even though it says 1 million contexts, it doesn't mean, it's not like a binary thing. You still want to keep your context small if possible.
Yeah, that's a really important point. There's interesting work being done with long context and on two fronts. One is performance. Typically, most autoregressive transformers, which is the technical term for next token predictors that are popular right now, like everything from GPT to Claude to Gemini, they have what's called a KV cache that scales quadratically. And that is just a way of saying that the longer your context grows, the square of that is needed for memory and for processing. So it takes a lot of processing to deal with a long context. I shared a martial arts themed video at the end of the year talking about some new US open LLMs. And one common theme among a couple of them was this hybrid architecture for Mamba and Mamba transformers, where you've got a linear scaling for a bunch of this, and you can deal with longer context from a performance perspective in a better way. But regardless of performance, which is something that we want to be able to load large code bases and large documents and have it work well, and have it work quickly, and have it work cheaply, there's this thing called context rot. And that is, people have noticed that models tend to start to suck. They just don't work as well. They get confused, they make things up, they omit things, and it just seems like they're being overloaded, kind of like humans, especially me. When I've got like too much going on, it's easy to forget something. So it's not ideal. I've noticed when I was using some models through OpenRouter that if I blew past their context window because they chose a provider that had a smaller window than the one that I wanted, it would say, this is not going to work unless you enable middle-out compression. Now, middle-out compression is a joke from a series called Silicon Valley. But they actually named their thing middle-out compression in OpenRouter because it literally takes the middle out. Because they say that the best things in the context are usually like the start of the context and the end of the context. And those are the things that LLMs are best at remembering anyway. So if you're going to do less destructive compacting, they figured they kind of just take the middle out. Now, obviously, that's not very sophisticated. That's not going to help you to capture and maintain useful information there. So this is an interesting area of research, and we're kind of digressing into a tangent, but it's relevant. Is how do we manage context? And the theme here is markdown context engineering. How do we engineer context so that we are efficient and lean, but we don't have too much information loss? And a big part of that is understanding what is necessary across iterations or across instances, and how can we distill the important things and discard the less important things. So you definitely hit the nail on the head there of like, this is a key principle here, is how do we manage context so that we can get the most bang for the buck, get the most information dense, but small length context.
That makes a ton of sense. And you don't want to anthropomorphize these too much, but it does. It tracks with human experience, right? I've been studying David Allen's productivity, the get things done approach, And the main idea of that is like the more stuff you have kind of churning in your brain, right? Like if I'm working on something, but I think, okay, I got to make that doctor's appointment for that kid, and I got to do this, and I got to follow up with this. And it's all kind of churning in your head. And his idea is you get it out of your head, put it somewhere else. So that way, when you go to work, you have the thing that you are focusing on, and you know that everything else you have a system of dealing with some other way. And so that would be, in human terms, it would be, I know that I trust my to-do list. And then in model terms, it'd be like, okay, a future iteration of Ralph is going to hit that task. I don't need to think about that task. I'm thinking about this task.
Yeah. Yeah. So, I mean, that is one common principle between these two things, is with skills, you can just load the skill that you need for what you're doing now. And, with Ralph as a paradigm, you just need to do the task that you're working on now. You're working on one thing at a time, and it is much easier to manage than trying to take on the world. So Ralph is an external bash loop that feeds information to a LLM session with a specific prompt, and then figures out if it succeeded, and if it didn't, then it keeps trying until it does. And then when it does succeed, it exits the loop. And before exiting, it does a few key things. It updates or appends certain files. So the key files involved here are, this is not totally descriptive here, but let me get here. This will help a bit. We've got a prd.json. So I think we're familiar. I'm going to start to show some stuff here with what is a PRD or a spec, which is a document that clearly lays out like what needs to be done in great detail and at great length. I'm working on this software I've open sourced that takes an image and creates an editable Google Slides presentation from it. And I want to create a front end so that we can run it out as a SaaS on a website. And so I'm going to use that as a toy project to try a lot of different agent harnesses and models and compare them. I think it's going to be an interesting, meaty enough, but well-defined enough project that I can repeat and evaluate. And it serves our purposes here too, where you've got some specification, we've got the background, you've got goals and non-goals, you've got some constraints. I created a file that has principles that then guide the creation of this file. Single responsibility principle, separation of concerns, keeping it simple, not repeating yourself. People are saying this is less important because things are easier to refactor, but then you still have to chase down many places to refactor. It still can create errors. So I still think it's relevant. Loose coupling and high cohesion. So based on these principles, then we look at some assumptions and decisions for the technical implementation and the architecture, system overview, components and the responsibilities, data model, API specification, a different engine, and execution model for workers, observability, the front-end specification, security requirements, local development, milestones, acceptance checks, acceptance criteria. So I'm pretty happy with this spec. It's very detailed, and I've just thrown it in factory, I think is what I used at that point, although I don't remember. I'm playing with various agent harnesses right now, comparing, and I've got a bunch of different branches here. So far, I've tried it with GLM 4.7, GPT 5.2. Originally, I tried this, fake LLM that was announced, and this thing was a hoax. Minimax 2.1, Opus 4.5, and now I'm going to try it with Ralph.
Okay, so for each of these harnesses, what you're doing is you're handing it your PRD spec and your principles, and you're saying, so for the harnesses, it's more of a, however they compact their context, whatever they do, or you can just tell Ralph to keep going. And Ralph could call, does Ralph call Claude Code, or does Ralph call another agent, or what does Ralph call?
So that's why there's various implementations of Ralph for Claude Code, which or for Open Code, or for Factory Droid. And we can whip one up for Open Hands. This is very portable because it's essentially just a bash script and a prompt and kind of a spec of how to do the spec, a meta spec. And
I have an example of Ralph. I pulled one up on GitHub. It is very simple. This is 80. I'll put it up for a second. Let's see if this works. Yeah, here we go. Okay, so just to go over, here's Ralph. It's most of this. Let me see if I can get rid of this thing here. Yeah. Okay. So what are we doing? Archiving the previous run, checking some branch. So basically saving your progress from last time, checking what branch you're on, and then here's the meat of it, right? Is saying, here's a kind of constructing your prompt and then calling whatever agent you want, in this case, AMP, with dangerously allow all, and handle the errors. And then what it's looking for is, Ralph eventually is going to say complete, and then otherwise it's just going to keep cycling on this, right? So I guess Ralph is prompted to print out the special string at the end when it's totally done. And so it's just you literally using grep to look for that. Otherwise, it is writing to the progress file. Like, it's very, very simple. Handing prompt.md to the agent, telling it what to do with itself, keeping track of the iterations. And then, like you said, that prd.json is right here. So what does it do with the prd? Let's see, if PRD file is copied to the archive.
Here, let me share my
screen. It's just tracking it. Cool.
I'll show you this diagram. It's probably good that you give the overview. I was trying to do in detailed one step at a time.
Oh, that's nice. Okay, cool. Let's check. This is much better than reading Bash.
Yeah. So basically, this is interactive. So you write a PRD, and then you convert it to JSON, which is what I was going to show. So this is a structured spec. And again, this is moving along that spectrum or balance between unstructured information or semi-structured or highly structured. So all of a sudden, this is not just a markdown file. This is JSON with specific fields in a specific kind of schema where you've got IDs, you've got titles, you've got acceptance criteria, and whether it passes or not. And that's the key thing that gets updated in each iteration.
Got it. And PRD is product requirements document, I just learned.
Yes. So then, you run your loop, and the loop it picks a story, AMP or whatever agent harness you use, and then it implements it. It writes code, it writes tests, and then it commits the changes. So this is actually kind of actively, autonomously committing to Git, which is something that is kind of scary for me. But if you manage your branches, it's actually really powerful, because then the Git log can be used as a system of record of progress and a way for the agent to figure things out. So I'm slowly releasing more and more control to the AI overlords, including making Git commits. So once it commits changes, if the tests pass, so you need to have a testable, and this is a key thing that is kind of glossed over here, is you need to have verifiable tests, verifiable way to know if something is done or not, or if it's correct or not. So if test pass, it commits the changes and it updates this prd.json, right? It would basically just search for the passes field and set it to true. And that way it's going to be in the set of things that are not needed to be implemented in the next iteration. And then it logs learnings to a text file. So this is something that helps it to kind of improve over time and figure things out with less trial and error and more success. So eventually, it might have struggled with several iterations for what relative path to use to load some library or something like that, but that it eventually figured it out. And this is stuff that you should have maybe had in your front-end agents.md or something. And that is another thing. And it's noted here, you can update your agents.md with patterns discovered for future iterations of other features. The difference here, and there's a key difference, is that agents.md is meant to be used universally in your repo for whatever you're doing with your repo. So it is completely independent from the feature or the project that you're doing on your repo. Whereas this progress.txt is for this set of cycles of Ralph. You know, like I'm not trying to build my images to slides program from this spec. I did that from another spec. I'm trying to do one feature of that suite, which is the SaaS wrapper, the web front end. So for this, I want to log progress into progress.txt, whereas for things that are universally useful for the repo, I want to put that in agents.md.
So the scope of progress.txt is a Ralph session.
Yeah, the scope of progress.txt is your spec, is what you're doing through these many loops that you're doing to implement this PRD. So the scope is the PRD, is the product that that you're doing, whereas agents.md is your repo, anything that you would do with your repo. Which maybe the first time that you run this, it's the same thing because it's a greenfield. But maybe the second time, like I already did, one round of spec-driven development and a whole bunch of manual tweaks to do the first part of the images to slide. Actually was doing a live stream on spec-driven development when I created the backend, and I did 80% of the 80%. And then I quickly then kind of finished it, but it's still this backend script. So now I want to do this whole other thing, which is I want the web front end, and that has its own PRD. And so how you kind of decompose these projects is something to explore. But then the idea is that each project, so to speak, will have a bunch of tasks. And that's the scope of a PRD and of a Ralph loop, of a Ralph's set of loops, right? Then each loop will be one task from the PRD. All right, I think that's clear. So progress.txt is scoped to your PRD, your thing that you're developing in your set of cycles here in your bash loop, whereas agents.md is for your whole repo. Then you figure out, do you have more stories? Does your PRD have stories that say passes equals false? If not, then you're finished. You did them all. So if you did them all, then you're done. And so that's the kind of the whole workflow for Ralph. So and I have a set of resources here, which I can paste into the chat later for each thing. Trying to do this in order, but I'm all over the place. But this repo was pretty useful. That's, I think, the same one that you pulled up that is for AMP code, whereas the DevRels head of Factory published this 3 days ago, right as I was going to try and kind of bootstrap it myself. So I'm like, oh, this is very useful. Each agent harness maybe has some differences in how things get installed. But at the end of the day, skills are skills where you've got things in certain directories. So here, there's a skills directory inside of a home /.factory directory. And so Ralph, so that's how and where you save your Ralph skill, I guess, globally to your user, not within a repo, which makes sense. That's kind of how you would want to do this.
Are you saying that from Factory's perspective, I thought, can you show me what it's copied?
Yeah.
Because I thought that that this would be a bash script for Factory as well, but if it's skill, it's a markdown. So this is, can you show me the skill.md?
Sure. So there's one thing at a time. I'm trying to do one tiny baby step at a time while showing the whole thing. We are here right now in this process. We're right here. So we haven't yet started to run it, right? So we need to convert the PRD to JSON, to prd.json. So that is what this thing helps with. Is if you take a look at this skill.md, it basically says step 1, understand the feature. What do you need to do? Ask the user questions if the person's kind of totally lost, or if the person knows what they're doing. Like, okay, create the prd.json, and here's the schema for it. And then, step 3, run the loop, right? So here's the bash script. So if we look at scripts, and this is where each agent harness is going to have their own syntax. How do you run this agent, right? You can run Claude Code, you can run AMP, you can run OpenHands, you can run OpenCode, you can run Droid. So in this case, we are running, if we look at the executable thing, we're running Droid. And this is where you tell it to run a specific thing. This is where you tell it not to prompt, just to do everything. I trust you. This is where you tell it, load it from this prompt file. And this is the prompt that it loads. And then, basically just go. And so this is the bash script, similar to the one that we saw that you showed quickly for AMP. This is its version for Droid. The prompt itself, this is kind of the magic of the Ralph agent. These are the instructions that tell it basically just, here's your task, do this, do your progress report like this, consolidate patterns in progress.txt, update agents.md, and have quality, test, stop when done, and just do one thing at a time. And keep your tests passing, right? So that the magic of Ralph is just a single prompt and a stupid bash loop. That's it.
That's so cool.
That's it's cool. Pretty cool. So I tried this. I didn't get too far because, as I mentioned, I was traveling, but I did get, I was I was on the plane. I was on the plane when I did this using the shitty airplane Wi-Fi. I was able to clone the repo and copy it to my factory skills directory. And then I loaded a Droid session. And I did pretty much verbatim what he said there. Use Ralph to add task priorities, right? So I said, use Ralph to add a structured spec with task priorities for, and then I mentioned that spec file that I showed you guys here, this spec file, right? And here, skill, you can see, this is how this agent harness implements skills. It looks in a specific directory, it invokes the skill loader thing, and it loads Ralph. So it's like, okay, Ralph, I'll use Ralph. I know that I have a skill named Ralph, and I told it to use Ralph. So this is the explicit skill loading method that I mentioned. And it loaded into Droid's brain, right, into its context window. And now it's got all the instructions inside of skill.md that told it what to do and how to do it. And so then it created the prd.json. So we can take a look at it. It should be here now. Where are we? Droid. I still only see this spec file. Oh, I'm inside the plans directory. That's why. And here it is, prd.json. I don't know what happens and why. I do not want to open Xcode. Compile error. I don't remember the syntax for PRD. I'll load it in Vim. So here we go. Here is the prd.json. You can see it created user stories. And by the way, one easy extension of this is I thought about actually using a proper task management system. But it's interesting to do this in Markdown. So it creates these user stories with IDs and titles and descriptions and acceptance criteria and priorities, the status, and notes. So that's the magic of this first function, so to speak, from the Ralph skill is the PRD creation. I've got this PRD, and you can see it's pretty detailed. It's 572 lines with 37 stories. So we have decomposed our PRD into 37 stories with acceptance criteria. That is a powerful decomposition that is going to allow us to then loop through this one thing at a time. Let's see how it works. Since this script is already there and it's going to run our bash thing for us, I think this kind of inverts the control again, but we can tell it to run the loop. So let's see what happens if I say run the Ralph loop. It's going to execute bash inside of the session, which
So this is Warp's LLM.
No. I'm inside of a Droid session. Oh, no, you're right. I was inside of a Droid session. So let me resume that. I exited out of it.
That's cool. I didn't know Droid does that. That's nice that you can resume those sessions. Okay.
Oh, yeah, that is very handy. So now I can say run the Ralph loop, which is not how I understood, Ralph was meant to be run. You're meant to run the bash script yourself, and that way each iteration runs its own session. But this is like meta now. I think we're basically having Droid run bash, which itself then runs Droid. Scripts, no such file. It didn't find the path, and then it found the right path, which is inside a factory, and there we go. So now it's running the Ralph loop and verifying the progress. So then this will run, who knows, it's 37 stories. It could take, let's say, 10 minutes a story. So it could take 10 hours. So we're not going to wait for it to finish.
So what's interesting here, so here's what I think that could be neat is imagine if you had some system in your PRD which could dispatch to particular LLMs or agents. So for example, if I was writing a full system, there's probably going to be some AWS component. And I could say, hey, why doesn't Kiro CLI handle the AWS component? The agent formerly known as Q. So Kiro CLI handle the AWS one. And then maybe here's a simple one. Let's throw that over to, a cheap local one. And then here's a really complicated one. We think this one's very difficult and touches a lot of things. Let's send this one to Opus 4.5 or GLM 4.7. That'd be kind of neat. I bet you could add in another field in the PRD or have somewhere in Ralph. And then this is sequential, but I wonder if you could add some kind of dependency language in the PRD so it could kind of be eager about getting these things done.
Yeah, there's lots of different ways we could extend this. I was just having a conversation in a WhatsApp group about LLMs and how the pricier ones are powerful and the cheaper ones are not nearly as good. But I had, well, why did you load that? had a different perspective on that, which was you can have small models that do powerful things because they're orchestrated and because you've got your problem decomposed to one specific part of the scope, and this thing could be specialized. So you could have a specialized small language model that maybe even runs locally and executes tools to do, like what you said, AWS operations. Instead of having one generalist runtime and one generalist model that tries to do everything.
And I think that, again, that kind of has this human parallel. One of the influencers I like is Cody Sanchez, and she's like, very business, get things done kind of thing. And she's just like, just start doing stuff, and you learn a hell of a lot by doing stuff. And you don't need to be this super genius to do stuff. And it's the same with LLMs. A lot of the stuff, if you can break the problem down, a lot of the stuff isn't that hard. It's just getting it into a cohesive piece, right? Often there's a core of like, okay, your core insight or core bit of genius. Okay, that's the human element or the very sophisticated element. Then a lot of it's, CRUD tasks and buttons and stuff that doesn't need the top of the line thing. If you say, okay, make sure this button exists on every page and make sure that it works. Okay, cool. You do that.
Yeah. I'm gonna exit out of here.
Because I want to see it running. If you can run the...
It's running. Just...
oh, yeah. No, I mean, I want to see what it spits out. It'd be cool if there was some visual of this, and I'm sure people have built it.
Yeah, and that's one of the things that I definitely want to extend this whole paradigm with is the visibility. One thing that I've greatly benefited from is the... what it's called, the reasoning traces of reasoning models and seeing how they think when they're doing things. So not only do you see kind of the final response, but you see what they're thinking. This is the task decomposition. This is not the very good example. Here we go. So seeing what a model thinks before it gives you its answers sometimes is more informative than the answers themselves, or just as informative. So seeing progress. Again, this is not something that runs on the order of seconds to minutes. This is something that runs on the order of hours to days, right? So it's not conducive to a live demo. But looking at progress.txt, and you can see what it learns along the way. Looking at your prd.json, you can see the progress. But so you can add a visualization layer on top of that, or as I mentioned, connect it to a task management system. So that is a powerful paradigm for sure. I'm excited to try it out, and I'm excited mostly to also extend it and make it my own and enhance it, because it is just dead simple. And there's beauty in that simplicity, and there's power in something that is designed, with modularity. So yeah, very excited about Ralph Wiggum.
Yeah.
I want to talk about Prose now, unless you've got some other last comment.
That's great. No, it's kind of, I got so excited about Ralph and all the places my mind's going. Oh, yeah, all right. So we built up pillars 1 and 2, skills, Ralph. All right, Prose.
Yeah. All right. So Prose is a way of describing a workflow in structured Markdown. This is yet another. This has just become a meme now. Create a TLD with .md. So you can go to Prose.md and you go to the website. MD is the hottest new top-level domain extension.
Congratulations, Moldova.
Yes. So this talks about creating a program. This is not terribly useful. You can go to GitHub here or Docs, and that's going to be a lot more useful. It basically talks about the language specification using skills.md. So this is how it activates triggers and onboarding and telemetry. And then Prose.md is how it actually runs the program itself. This is the kind of the language reference. This is a very detailed spec. Let's go to the root of the repo, and we'll see kind of a easier documentation. This gives an example of how you would have a Prose program. This is a multi-agent orchestration and workflow control inside a Markdown document. It runs inside the runtime. So here I'm defining an agent, giving it a name. I'm specifying what model to use. So to your point, specifying a different model for different things. I'm enumerating skills that it can use. Now we know what skills are, right? So we could have a bunch of different skills, and we have a list of skills. So we can have agents with certain models with a certain set of skills. Here's another agent that's a writer agent that uses a different model. And then here is a workflow specification saying, in parallel, I want to have a research session that uses the researcher agent. And I'm going to pass it this prompt, which is research quantum computing breakthroughs. Then I want to have this competitive session that uses the researcher agent to analyze the competitor landscape. And then here's a loop where you say loop until, and remember when I said ambiguous thing that AI defines, notice this double asterisk. Everything that's inside the double asterisk is evaluated by an LLM to interpret. So up to now, this is a kind of a hard spec with a specific syntax that is used by kind of this virtual machine inside the AI runtime. And then right now, we're kind of breaking out into AI interpretation, where the draft meets publication standards, right? That's not a deterministic, hard spec thing. That is a hand-wavy thing. How do we determine if the draft meets publication standards? Well, let's let the LLM decide. And so that's what's happening here when we surround something by double asterisks. Is we're saying have the LLM determine this thing, and that's used for flow control. And so then what is used inside the loop is you've got this writer agent, and you pass it this prompt, and you pass it this context. So you can see this is a great complex but compact example of flow control with multi-agent orchestration, where you've got a parallel execution of different agents with their own context. One researching quantum computing breakthroughs. This is not a very good prompt, because if this is done in parallel, this doesn't know a competitor landscape of what. So you'd have to kind of specify that better. But then once you have these two things, you can have those things in as part of the context, their output, for this loop that keeps writing and refining, writing and refining, writing and refining, until the evaluator then determines that the draft is ready for publication standards. So this is what they call inversion of control, because instead of having something external controlling the flow control for LLM execution, you're having the LLM session itself create subsessions, create multi-agents with their own contexts, create the criteria for flow control.
So I get that up until the parallel part.
Yeah.
How does that, well, I guess that depends on the harness to be able to run things in parallel.
Yeah, because there's things that can execute sub-agents. And so the example here is, here's a Claude Code plugin. And so basically, here's with AMP. And you essentially run different sessions with their own instantiation. It's my understanding of it. I haven't run it and inspected it yet. I did do one run of this. Let me see where this lives. Trilogy writing. This was maybe for deep research. Oh, for evac. Let's do this. Find dash name startup prose. Okay. Oh, this was here. I loaded it here. So here's there's this skill that you can load to create that prose file for you. So this prose file has this same syntax, but it's it's fairly complex. Like this is English as code. English as a programming language. It's 100 lines. It would be a pain to write that from scratch, but you can have an LLM write it, and then you can edit it and refine it. And so I basically did this. I loaded, and I think this might have been in open code. Let me try it. Load the prose skill. Open prose skill is now loaded. All right, so I've loaded the open prose skill into the open code agent harness. And so I can have it create a prose file. So we've got a little bit of time. This won't take very long. Let's think of some kind of multi-agent orchestration that we want as a toy example that is just amazing that we could kind of vibe. It's not even vibe coding, it's vibe writing.
All right, well, here's a question that's on my mind. And this I can use. You have web search skills at your disposal, right? So why don't we ask it to do some research on whether I should buy an RTX 3090 or a 4090? And so I guess we need a research agent for that. And then we could also have some type of synthesis agent that would tell me what models I could possibly run and what performance I would expect given each of my choices.
Okay, I've got an idea to make that kind of simple and fun.
Because I went down a bit of a rabbit hole this morning.
Yeah. Create a prose file to do product research on specified alternatives. Evaluate their cost benefit value proposition. And then pitch the recommendation as a pirate. All right, so now it's creating a product research workflow with a pirate pitch finale. And there it is. So here's our prose file. Product research prose. Let's take a look at that file. Here's the overview. Gathers product alternatives from you. It researches each product in parallel, pricing, features, limitations, user sentiment, analyzes cost-benefit value proposition with rankings, recommends the best option with justification, pitches the recommendation as a swashbuckling pirate captain. So then you can just say run productresearch.prose to try it. But first, let's take a look at at the Prose file. So here's, whoops, yeah. So you can see here's the session name. Here's a prompt for gathering the product list. Then research each product in parallel. So here's parallel workflow, research results, session deep research, research this product thoroughly, product, find pricing tiers, blah, blah, blah. Evaluate the cost benefit for each. So here's another session, which is cost benefit analysis. And then make the recommendation, final recommendation based on the cost benefit analysis, select the best product for which cases, justify it, right? And then the final session is pirate pitch. You are a salty sea captain who salted the 7 seas of software, delivered a product recommendation using rousing pirate speech, using nautical metaphors, etc. So let's try this. Say run product research.prose comparing RTX, what was it, 3090 and 4090?
The 4090, yeah.
RTX 4090.
So it is amazing. The RTX 3090 is a 6-year-old GPU that is still on eBay for $1,600, far more than what it cost new 6 years ago. But with this insane arms race, that's just the way it is.
All right, so it's starting now. This is why we're calling this a virtual machine. It's executing it, inside of this runtime. It's starting this program. It's running. We wrote a program. That's what this thing is. This is a program, and it's now executing it. So now it's here. It extracted a list of products, and it's running in parallel. RTX 3090 and RTX 4090. And so here, subagents, Control X write view subagents. Here's a subagent where it's running RTX 4090 research. Control X write, oops. Control X up.
Wow. Okay.
That's a problem with the key bindings here.
Oh, because your mission control key binding is stealing that.
Yeah. So we're now seeing this specific sub-agent session for the RTX 4090.
I agree with the negative feedback there. Price is absurd. 5 exclamation points.
Yep. Bottom line. So previous Control X left. But yeah, that is just changing my workspace. I don't know if I can get back to my main view now.
Oh, gosh.
Yeah, I know OpenCode is working on integrating more mouse actions in their terminal UI. So hopefully that'll be a way of getting around that. But it looks like we've completed this parallel run. Unfortunately, I can't get back to my main session. But so yeah, I mean, you saw how easy it was to create a multi-agent workflow using English with a simple prompt saying, create me this product research and pirate pitch. I'm going to be really bummed if I can't hear the pirate pitch now.
Okay, so while you're looking at it, here's a question. Do you think that calling it a virtual machine is marketing speak or is fair?
I mean, it's fair because it's a computer is something that executes instructions using a syntax. And this is what it's doing. And it spawns sub-agents. It's like launching a sub-process. It is absolutely a fair comparison.
But it's interesting because you think of the execution environment. Well, I guess this is what highlights that big difference that we talked about. We were talking about earlier is that the execution environment really depends on your harness. It's not just the model anymore. That like the model is like the brain in the jar, and like we talked about this. if you remember the Ninja Turtles cartoon, there's that villain Krang, which was like the brain in the jar, and then it had that whole mech suit around it that could actually make it do stuff. And the raw smarts of the model only gives you so much, but what it can actually do and how useful it can be is highly dependent on the harness and the ability to do this web search and do things in parallel and pick different sub-agent models. Like all that stuff is the harness. It's not the model.
Yeah. So I mean, this is part of the inversion of power here, and this is very relevant to a whole other talk and article I want to write about something that went down over the weekend with Anthropic, cutting off access to open code, which we're using right now, to their Claude Code subscription plan. And that is that models are becoming less sticky. It used to be that, if OpenAI or Anthropic had the end-all, be-all, top-of-the-line model, nobody could compete with that unless they had gazillions of dollars. But now LLMs are starting to be commoditized, especially with these powerful open-source models that have created a very healthy competition in this space. And with the sheer power and intelligence of these agent harnesses, so that not only do you have a good enough model or a nearly as good model, but you've got orchestration mechanisms to inject a lot of intelligence into how these models operate on a problem, which means that then companies can no longer have models as their moat. And they're now trying to figure out what their moat is. Is it their developer ecosystem? Is it their agent harness? And maybe you shouldn't get your agent harness where you get your model. You should have, there's like the CEO of a factory wrote an interesting blog post saying, marry the harness, date the model, marry the harness, which is like, you should really, lock into your development tool flow with your agent harness, but you should be able to hot swap your models. Have different specialist models for different things. A new model just came out. You've maybe seen the whole meme of like, oh, you are here in a cycle of, the leading model is Gemini. Oh, now the leading model is Claude. Oh, now the leading model is GPT, and that's going to change. And so you want to be able to swap out your models, and the driver around all these things really is the harness. But so where we're getting into uncharted territory here is the harness isn't even necessary or instrumental in some of the orchestration now, where you can do that in a bash loop with a certain prompt, or you can do that with a certain specification of how to spawn sub-agents. Like now we're getting to the point where your context is so powerful that it can be the driving factor and the determining component in the execution of whatever you're doing.
Well, I think there's a very interesting and informative discussion. I'm definitely very motivated to try out Ralph and to try out OpenProse. I'm curious more as to where OpenProse fits in, whereas Ralph, it seems like, anything that you want to try that's spec-driven. And so I'm very curious. I think we'll have to do a follow-up episode of wherever you found that the ceremony of OpenProse fits in. Is it for repeatable, like, we did this product comparison task, right? Where that's in some senses very repeatable, where you want to make sure, and you can have very specific sub-agent tasks. Like maybe you are a real estate agent, and you say, compare this house and this house. You want to say, check this database and check this database, and do, you can have it be very, very specific to your workflow for lots of repeatable tasks. So I could see that being very, very useful.
Yeah.
Okay.
Let's try one more run here. I off to linear this time. So I'm gonna do another fun thing. I'm gonna say load the Prose skill. And you can see this time I'm using GPT 5.2 codecs because OpenAI collaborated with OpenCode to allow them to use their subscription, which means not only do people not have to pay per token API pricing, but they have access to this model that isn't even available via API. You know, it's kind of amazing. So let's see. Create a Prose file to load my issues from linear. Determine the highest priorities. And give me a folk poem I can repeat as a mantra for what I need to keep top of mind.
Let's see what's in your linear.
All right, so yes, anonymous, no thanks. Disable telemetry.
Okay, so this is open code that you're using.
Yes.
If you're here in the chat, what harnesses are you using? Put in your harness. I've been much more sticky to Claude Code than I should be. I've been using Gemini a lot. And I switch between Gemini and Claude Code, but I need to try AMP. I need to try Open Code, also Open Hands.
Yeah. There's lots of things we need to try now. Okay, so here we go. Right, this one doesn't really take arguments.
So
linear priority mantra .prose.
So is this doing context compaction between this? Because these are all subagents, the first two. Like by the semantics of
Prose. It doesn't need to.
No,
yeah,
okay.
so those are they have their own context. Yeah. No. Okay, so let's see what happens when I do this. So this is a linear workflow. It's different than the other one that was parallel. Because the other one, you could research those two products in parallel. Here, first we need to load the linear issues. Then we need to determine the highest priority issues. And then, we write the poem. So that's a linear workflow.
And it knows you have a linear MCP server connected to this, I presume, and that's what is talking to linear?
Yeah, you saw that off screen that it loaded up. So
yeah, okay.
I was like, okay, since this thing is continuing to load, let's make use of it. Oh, I was waiting for me to confirm. And so now it's building. Task, open Prose session. I'm not going to do this. I'm not going to go to view the subagents. Open Prose session 1, tool call, linear list issues. So now it should be listing the issues. Tab agents. And I want to take a look at that Prose file here. All right, so this is a very simple one, much easier than the research to publish. This was one that I created to try and create a writing workflow to do deep research and to then write an article. I was going to try and automate article writing. And I mean, it did a fairly good job of writing the Prose program, which I then ran, and it did do deep research, and it did do, all these parallel tool calls and loops, and like they did this whole run. I wasn't totally satisfied with it. I probably would have to iterate on it quite a while before I was saying, hey, I can just run this in one shot an article. But I was amazed by how easy it was to do, mostly because I didn't have to write this by hand. I wrote a prompt that wrote this. I wrote a program.
And having that locked in, because it's easy to kind of explore and kind of video game it, vibe it, so to say, but then you can't repeat it. And so to have that locked in to a file, that's really powerful.
Yep. So here we go. Here's its mantra. Interestingly enough, it chose to put the task items. It's not very useful for me to repeat as a mantra because I don't know what those things are. It lists them there. I'd have to memorize them. But you can see, it pulled in all my issues. It determined the priorities. It figured out, okay, my top 3 priorities are the live stream that we're doing right now. Then this literature review for that software that I mentioned that turns images into slides. I'm submitting it to a conference. I could present it as an academic article, but that's due tomorrow. So here we go.
All right.
So yeah, that's pretty much it for this presentation. I'm going to talk about briefly some finishing thoughts here. What did these things have in common? Versionable text. You can commit them to Git. That means you can share them with other people. You can, like you said, having this locked down where you're not trying to do prompt engineering on the fly. You're able to iterate on something and refine it and share it with people. The fact that you can progressively load things into context, so you only have as much as you need to have at any given point, and then based on what you're doing, you can load the entire file. You can even load external files when you're calling a function that is defined in the file. Composing things, skills, tasks, workflows, decomposing things, the ability to take a giant project or a giant thing and break it down into parts so that you can work on one part at a time with efficient context, with specialized instructions, specialized models, verifiable processes. That's very key. And having the clear success signal, the things that I just mentioned, the verifiable things, so that you know whether to change it from fail to pass. That is the determining criteria that's going to make something like Ralph successful or not. Operational patterns, being able to repeat the same instructions. So if I find a workflow that works for product research, with the right prompt, with the right flow, then I'll be able to, do product research between different things for family, different things for my computer, different things for nutrition or whatever. Being able to have repeatability. Auditability. Humans, even non-technical humans, having somebody be able to go through a Prose program and figure out, a writer could look at this and edit it and refine it. And they don't need to know LangChain. They don't need to know Python. They just need to read this text file and they can understand it and they can improve upon it. So that is very powerful. Separation of concerns, and being able to understand, this is interesting because that's one of the principles in my spec-driven development, is being able to have things in their different place, taking care of their thing without having one thing trying to take care of many things. And then portability. You saw here I used Factory, I used OpenCode. I didn't get a chance to load. I was going to try, and I'm going to try this next, is OpenHands has a headless mode. So that's how I would be able to invoke in the same way that we saw with AMP and with OpenCode and with Droid inside of a Ralph loop. And so then you can take something like Ralph, you can take these skills. These skills are supported by all those different agent harnesses. So that portability is really key, that somebody can come up with an innovative thing like Ralph, and it works on all these agent harnesses. Agents.md is supported by these harnesses. Let's say that I come up with a really good product research and recommendation in pirate speak thing that is so viral that everybody loves it. They can load it into whatever their favorite agent harness is. I'm not forcing you to use, one or the other. It's portable, and that's the beauty of open standards. And then, what failure modes you want to look at? We need to have clear verification signals. You can't have fuzzy goals, things that are too broad or too narrow. So you want to have that kind of perfect temperature of porridge, of having the right amount of things in your skills files. But overall, I think this is going to be a great thing for the ecosystem to explore.
If you scroll up for 1 second, there was a comment. A lot of the engineering patterns and operational patterns, it's kind of the exact same thing that's important for humans getting things done. Is what are success? I was actually just reading and Get Things Done yesterday. Like one of the most important questions of anything is, what does it look like to call this successful? And it's amazing how ambiguous that is. And one of the most important exercises is like sitting down and defining, what does success look like? Hey, we got a question in the chat that I want to put up. I said, who's using what harness? We got Gemini, we got Claude. Also, what model are you using?
Okay. So first, to just piggyback on what you were saying, I think part of the beauty of the Ralph paradigm and decomposing things and structuring things is this acceptance criteria. What a pain it would be to do this by hand. You would need a dedicated full-time project manager, right, to create stories in Jira and acceptance criteria and all this. So you get this for free, with the intelligence of an LLM, and then having acceptance criteria as part of your success criteria, having verifiable tests that run, that's gold. Yeah, for sure. What model do I use? Depends on what I'm doing. It depends on the day of the week. It depends on the time of day. I'd say this is a fluid situation. Right now, I'm in Flux, actually. Not the Flux model. I mean,
you're dating the models.
Yes, exactly. I'm doing this this thing here. Where was I? Here, right? Git branch. Here are the branches that I've tried so far. I'm trying to do this head-to-head comparison of GLM 4.7, GPT 5.2, Minimax 2.1, and Opus 4.5. I'll say those are, four of the most compelling coding models right now. Gemini 3 Flash is interesting. I'm not seeing it used a lot in the field for programming. I do see that it is very powerful for some front-end stuff, and it is definitely extremely powerful for multimodal operations. So I would say that Gemini's multimodal capabilities are ahead of everything else. So if I'm trying to understand something that's visual, I'm going to use Gemini. So that's kind of one of the things that I'm using for the images to slides thing. Here, I think I can load this up. GitHub, images to slides. I think this has a video here, right? So here I take, wasn't there a video? Here it is.
I'm putting the URL into the chat of this repo if you're going to follow along. So there's the URL.
So this takes an image and analyzes, bounding boxes, text areas, images to clip, and it stores them, and then it uses them to programmatically create a Google Slides thing. So for the VLM, the visual language model part, I'm definitely using Gemini for that. There's nothing else that I would use. So I would consider Qwen 3 VL as an alternative for an open source thing. But yeah, I would say Gemini 3 is very good for that. And you can see how well this worked. This is why I want to present it at a conference.
Here's a question for you, Leo.
Yep.
I don't hear much from Llama 4 recently. Are
No,
they?
no, Llama's dead. Llama's dead. I don't know what Meta's going to do. You know, they were going to come out with Behemoth, and they never did, right? They're like, what's the point of putting out this thing that is trillions of parameters large and sucks, right? So I don't know what Meta's going to do. I think they may be giving up on writing models, and they may focus on things outside of frontier models. We'll see.
Facebook dating.
Yeah, I'm gonna. However, there's new players in the model space, so who's to say if somebody brand new can come up with a model, why can't Meta do it? You know, it's not like it's a race that already is underway and it's too late to start. It's more of a structural thing that needs to happen. I don't know. But I do want to talk a little bit about models since it was asked.
Well, and we have another follow-up question. What model do you recommend for back-end or AI ML programming?
Okay, yeah. So, and this is like in response to the discussion that somebody was asking about what to use for a certain thing and whether to use LLMs via API, and somebody said, that is very expensive. And I said, yeah, but there's cheaper models coming out all the time. This is speaking of multimodal, LNAI, the makers of Olmo, the most open model in the world because they share everything, like how to build it, the data, the training recipes, etc. They came out with an open vision language model yesterday, I think.
8 billion, so you could run that.
You can run that locally, yeah.
That's why I'm looking for that RTX 3090.
Yeah. So I want to highlight this. Minimax, 27 cents per input token, right? And this is a highly powerful agentic model. Minimax is definitely something to keep an eye on. GLM 4.7. A little pricier, 40 cents per input token. But you compare that to like Opus 4.5 pricing. That is
premium.
$5. And you know, they brought that down from like $15, right? So we're looking at one order of magnitude here. So that is huge. Gemini Flash 3, it's very interesting that Gemini Flash 3 is now competing with these Chinese models on price. This is cheap, 50 cents per million input tokens. So I think this is a powerful model. I mentioned it's not my go-to for programming, but maybe for some front-end stuff or for a quality assurance layer that takes a look at a screenshot of a front-end and determine something, I'm sure. For visual reasoning, for sure. But one thing I want to call out here is two things. NVIDIA Nemotron, which NVIDIA has put out this new, this is that Mamba transformer hybrid that I mentioned. Look at this price. This is the free one. There's a free layer. Great. Yeah, it's a great price. Yeah, but you have limited free usage. 6 cents per million input tokens. And this is a decent model. I mean, it's not like GLM 4.7, but if you're looking at operating on things, not necessarily maybe doing spec-driven development, but maybe like you need to process some data or you need to do some things, like consider this. Like, first of all, you could run this locally. If you have a powerful enough, GPU or a computer with unified memory, it's definitely something to consider. And then second of all, DevStrawl 2. A lot of people don't know that this came out. The first one was a bit of a flop, but the second one is amazing. Amazing. I mean, I wouldn't call it a flop, but even OpenHands collaborated with them, but it just, was eclipsed by all these other models. But DevStrawl 2 on the Pareto frontier is amazing. And look, again, I opened a free one.
5 cents per million.
5 cents. 5 cents per million. So now we're talking 2 orders of magnitude difference from Opus 4.5 at 1% of the cost. So obviously Opus 4.5 is way better than DevStrawl 2, but is it 100 times better? How can you quantify that? If you have the right orchestration in place where you pass little components, little sub items that take a look at that PRD and load one thing from that thing, like maybe it's worth considering this swarm of cheap small models that run at 1/100th of the price as frontier models.
Well, and to think about, a swarm of cheap, small things is how we got, the personal computer, right?
Yeah.
There has always been that tension of the small, cheap commodity versus, the big mega mainframe. And I think there's room for both, just like there's room, for these small, cheap models. And you think, okay, one shot with Opus or 100 cycles of Ralph.
Yeah.
I think Ralph will probably get it in less than 100. I wanted to answer your question. I'll give another opinion on the back end part. I found it really, really useful. This is highly opinionated, but that's good, I think. Use Supabase. Supabase has it runs on AWS, but it has a very just opinionated set of ways to do edge functions, which are its like version of Lambda functions. It has a way to do authentication. It gives you a SQL database. It has an excellent SQL server. So you can get into Supabase. Their free tier is really good, and you can just say, okay, give me row level security where only admin users can change this field in this database, and it'll generate the right SQL to do that migration. I'm very happy with Supabase just for my personal projects. I found it to be useful. If you're using the AWS stack, you could probably use Kiro CLI for the AWS parts. So I think it would depend, to answer the question from our viewer, I think it really just depends on what your stack is. I do find the Supabase MCP to be really useful. And also if you're doing heavily AWS, use Kiro. Otherwise, if you're using, if you are using Tailwind and React, maybe start in Lovable and then at some point git commit and fork over to, go over to open code.
I would not start in Lovable.
I found Lovable is pushing too hard their Lovable cloud, which kind of doesn't go anywhere, and I don't like that.
Yeah.
I think it's fun for prototyping.
I think a key thing definitely is speaking of portability, is being able to switch between tools, and that is my dissenting piece from the marry the model. Marry the harness. I'd say date the models, and have an open relationship with the harness. Maybe you can see other harnesses
might
too.
Be dying. Yeah, I think that makes sense. I think it's definitely you want to be able to swap harnesses. Lovable I thought was really good initially, but I don't like the Lovable cloud just because it's too its own thing. And I don't think, and once you use it, you kind of can't port your projects away from it without a bit of work and rewriting. Google AI, and of course, like the Google AI Studio is great if you want to stay within their ecosystem. But I think in the end, the open stuff will probably do really well. And like I said, you also want to make sure it's reproducible.
Yeah. It's a tricky thing to know which model to use. I think the important thing is to be agile, to be able, and that's that same thing, be able to use different models and to change models. Like we have to adapt and we have to change even our workflows. Now I'm looking at, changing a lot of things that I was planning on doing because I'm learning about new things. So the important thing is to find a way to try things out and figure out for yourself, as well as find a community, find a set of voices that you can learn from, because you have to be constantly doing both of those things. You have to be finding out about breaking things and learning things, and you have to be able to try them out yourself and see how they work for you.
Yeah, it has never been a better time to build stuff. It's an extremely exciting time. Well, I think with that, let's wrap up. Any other questions? Thank you for being here. Everyone's here. We are going to probably hang out in the Discord for a little bit, and I've got the link to the Discord. That's kind of posted everywhere. Let's see if I can post that in one more time. Let's do over on Discord. I'm going to take the invite link. Here we go. I'll drop this in the chat. We have a Discord where you can ask questions about AI. We'll inform you about all our upcoming content, live streams. Thank you for joining. Thank you, Leonardo, for all the preparation. This is a lot of food for thought. All right, we will see you all next time.
Thank you.